All right, in this problem, we are looking to find the angle of elevation and also the height of the ladder. So we're given a building with a ladder that leans up against it, and we're told that the ladder is 34 feet long. It's leaning against the building. The base of the ladder, which would be the bottom of the ladder, is 7 feet from the base of the building. And we're trying to find the angle of elevation of the ladder. That's going to be the ladder coming up from the ground. So this is the angle that we're looking for. And we also want to find out how high does the ladder reach on the building. So we're trying to find the height of the ladder up on the building. So we have to go back again to our trig ratios to find this. And you need to be smart about the angles or the trig ratio you choose. Look to see what you're finding. So in this case, if I want to find theta, what trig ratio can I use? Well, with the angle of theta, this is my adjacent, and I have the hypotenuse. So going back to my trig ratios, I know adjacent over hypotenuse is cosine. So I know that the cosine of theta is equal to 7 over 34. To find the angle, I'm going to find that theta is equal to the cosine inverse of the 7 over 34. And when I put that in my calculator, I'm going to use degree mode because I'm getting a degree out. So because I'm looking for the degree, it will be 78 degrees. So make sure you're in the right mode. So that finds my angle. Now I want to find the height of the building. And you can do this a couple of ways. You can use the Pythagorean theorem, or you can use another trig ratio to find it. I'm going to show you both so that you can choose either way you want to do it. So doing the Pythagorean theorem, you would have a squared plus b squared equals c squared. It doesn't matter if we call this a or b. It doesn't matter. We can say that we have a squared plus 7 squared equals 34 squared. We know that this has to be c because it's our hypotenuse. So we have a squared plus 49 is equal to 1,156. Subtracting our 49 over, we get that a squared is equal to 1107. Taking the square root of both sides, we get a is equal to 33.3. Now we know it's not plus or minus again because we're doing a distance, so it will just be the positive of 33.3. Or you could choose to do another trig ratio. So if I'm looking for the opposite of my theta and I have the hypotenuse, or I'm looking for the opposite and I have the adjacent, I could either use sine or tangent. I'm going to do sine. So I could do the sine of my angle because I have that now. The angle of 78 degrees is going to be equal to that height, whatever you want to label it. You can do it A or B, over the hypotenuse of 34. So I multiply both sides by 34, and I end up with 34 times the sine of 78 degrees is equal to h. And when I plug that in the calculator, I will get 33.3. So I got the same value, you doing it two different ways, whichever way you feel more comfortable. So the angle of elevation of the ladder is going to be 78 degrees, and the height is going to be 33 feet. You can put it to 33.3 if you want. I'm just going to round it to the closest foot. The next problem that we can look at with the angle of elevation is going to be a problem using a tree. So a 97-foot tree casts a shadow that is 217 feet long. What is the angle of elevation of the sun? So again, we're looking at where our parts are that are given to us in the problem. So the height of the tree, that's going to be 97. The shadow is going to be on the ground here, where the tree is putting its shadow down, is going to be 217. Now, we are looking for the angle of elevation of the sun. That's where the sun comes up from the horizon. So this is the theta we are looking for. So here we have the opposite and we have the adjacent to our angle. And the trig function that goes with that is tangent. So tangent theta is equal to 97 over 217. So my theta is going to be equal to the tangent inverse of 97 over 217. Putting that in my calculator in degree mode will get me 24 degrees. So my angle of elevation is 24 degrees.